Hello, Andre. Welcome to the show. Andre, please do tell us, where are you joining us from? Who are you and what do you do?
Andre, you are on mute. You want to unmute.
We have you on mute.
You have on mute.
Coming from land of mute.
So I'm joining from Dublin, Ireland. I'm currently in Dublin, which is arguably very close to where you are.
Yay,
so my name is my name is Andre Belik. I'm a senior product manager at ElastiCache. And,
excellent. Yeah. So the second part of this live stream is about a new feature coming from our wonderful friends at ElastiCache. As you can see, this entire day is about in-memory databases. So we're just going to be continuing on the same topic, but we're going to talk about a new feature today that's coming from ElastiCache. Andre, can you tell us what is this wonderful new feature you're releasing?
So the new feature we released yesterday is auto-scaling for ElastiCache. So now, look, obviously ElastiCache is a managed Redis, and yesterday we released a feature that was actually requested by lots of our customers, and we can now enable auto-scaling on the clusters with Redis, and ElastiCache for Redis will manage auto-scaling, scale in and out, horizontal auto-scaling, I should add, automatically for you. So that's a kind of a main release that we've done.
So maybe we can step back here for a second, right? We talked about Amazon Memory DB, that it's this more resilient Redis implementation. But tell us about ElastiCache. What is ElastiCache, and why would our wonderful folks in chat here and people watching us use ElastiCache?
So, okay, let me kind of do maybe a high-level introduction again, just for people joining. So ElastiCache for Redis is, so ElastiCache supports two in-memory databases, Redis and Memcached. So this feature is specifically released for Redis, and Redis is the in-memory database that provides sub-millisecond latency. So it's considered to be a cache or in-memory database, and it's really designed to power kind of internet scale and real-time applications.
Okay, so when it comes to ElastiCache, we support both Redis and Memcached. Is that how we pronounce that?
Memcached. Yes.
Memcached. Okay, I always thought it was like Memcached.
And we've already talked a little bit today about the different types of dimensions and about durability, and ElastiCache as being potentially, if you have a really high write volume, you're going to see faster write performance potentially and lower costs with ElastiCache. So that kind of, I think I'm starting to get an understanding of ElastiCache and MemoryD compared. When I consider the two, now I have the ability to auto scale out a ElastiCache cluster if I have a considerable amount of write volume compared to if I have a mostly like read volume based approach, but I do need those durable writes inside of MemoryDB.
Yeah, so the ElastiCache for Redis, the internet applications, they tend to scale, they go up and down. There are different cycles in the world. When different regions wake up, there is a different traffic, different customers start to use service. And if applications kind of are deployed or services are deployed at a particular level, they can't really adapt to this traffic themselves. So with this release, we are trying to target and provide a bit more of an optimized resource allocation to match that performance requirements that comes from the customers and using applications and services.
So that's interesting. They're talking about optimizing the usage. I think I said earlier on the stream that I've been using Redis for over 10 years now. And I remember when I first started using Redis, this idea of scaling out Redis was very difficult. Yeah. We didn't have Redis cluster back then. And so we actually did it in the application side. We had our own application side code that had a list of Redis leaders to talk to. And then we would do a hash on the key we were writing to. And we'd try to calculate, okay, we're going to communicate to this particular Redis. And I remember it was very difficult because if we wanted to adjust the list of Redis servers or add another one, now we had to do all the rebalancing ourselves. It was very, very challenging. And it worked, but it required an incredible amount of operations. So maybe you can talk a little bit about the history of the scaling and how things have improved leading up to what we can do now today with this new feature.
So I think around Redis 3, I believe, if like my memory serves me right, the Redis released the kind of cluster feature where you can distribute your data across multiple shards. So each shard essentially represents its own set of keys, and the Redis has a way, and there's a new protocol for that as well for the drivers, to find out which keys are stored on which shard. And that provides a very classical horizontal scalability for clusters. So I can increase amount of keys I can hold by just distributing them across a variety of different shards or kind of multiple primary nodes, and each primary node will store its own set of keys. And each of those nodes, primary nodes, could also be replicated into its own secondary nodes to provide that kind of durability for and maintain like multiple copies of the same data in memory, which will provide higher read throughput, but at the same time provide a little bit more durability and just kind of guarantees that if it goes down, there is also cache present on both worlds. And what typically we've seen over the last couple of years is that our customers would, so we released scale in and out APIs, the manual APIs, a couple of years ago at this stage. And we just found some of our customers start to use it. So with this feature, we really like to kind of bring this value proposition a bit more and actually provide that functionality ourselves.
Wow, so now it will automate. I don't have to go in there and do a manual API call to adjust those shards. It can actually adjust them automatically. So what are the dimensions that I can actually auto scale on, and when might I use like one dimension versus another?
So we support in 2 dimensions. One dimension is we can scale out in number of shards. And what that will achieve, so if we scale out, we increase number of shards, and that will increase the amount of writes that applications can do. It will increase number of reads as well because there is more server requests. When we scale out, we'll automatically rebalance the shards, so all the keys will be redistributed equally and accordingly across all the new shards. But also it will provide more memory. So there is more cache more values could be written into cache. And because there is additional servers kind of having available memory. Second dimensions is we can increase number of replicas for each shards. So the replicas will be increased equally across all the shards. So if I have 3 shards with 2 replicas, if I scale out, there will become 3 replicas for each shard. And that will typically increase amount of reads we can do. Because again, Redis typically used as a cache to very fast read data and make it available for applications. So increase the number of replicas is a direct will be proportional to increase amount of read throughput. However, it's when I increase number of replicas, because they're the same copies of the same shard, they will have absolutely the same amount of memory. So that's where the balance should be kind of stricken between increasing number of shards or increasing number of replicas.
So Andre, that was one I wanted to bring up.
This is exactly what I wanted to highlight. Franklin, what are the conditions to rescale your cluster? So if I understood correctly, let me see if I got this right. So if my data is growing too big to fit in memory on one node, then I would want to add shards. So that way I have more space to fit data. If I have really high writes, so that way the shards can't keep up, then maybe I also want to split that across shards. But then if I have really high reads, then I might increase the number of nodes. So the 2 dimensions are shards and nodes. And depending on what's the use case, data growing too big, number of writes, or number of reads, that's how I choose which dimension to rescale on.
That's right. Yes.
All right.
You got it, Nathan. There you go. So how does this auto scaling, like, how does it actually work, right? What is it based off of? And, let's talk a bit more what is this and how does it work and all those kind of things.
So one beauty, I think, and what I really liked about this feature and implementation is we actually did not write our own auto-scaling service. We use AWS application auto-scaling service. So the service that is well known and understood how it's used. We just using it as any other application might find the use of it. So what we essentially do, majority what our feature does, it's automates and orchestrates synchronization between ElastiCache for Redis and AWS application auto-scaling service. So when we configure the scaling, and I'll do a demo later on, we can set thresholds and like a target or schedule when we want to scale our cluster. And we'll set up different communications, alarms and CloudWatch metrics and we'll provide them to application autoscale service. And then the service will actually do heavy lifting in deciding when to scale out or scale in, and will send us commands over the same APIs that we have for a couple of years to scale out or scale in our shards or replicas. So it's just really an orchestration, but we use kind of well-tested and kind of battle-tested services within this new release. That's why we actually announced it as a GA kind of only yesterday.
I have a question here. I may have missed this. Based on what metrics are you triggering the autoscaling? What are you looking at?
So the application, AWS application autoscaling supports two modes. One is called target tracking, and one scale out or scale in based on time durations or occurrence, daily, monthly, based on cron jobs. Second is the target tracking, and with this feature, we actually provide three new metrics. To scale shards, there is two metrics. One is the average memory across all the cluster. So we can target that metric and say, okay, if it's hit 70% or hit 60%, scale out, or if it goes below that, scale in. Another thing is CPU or primaries. So because we need to track the performance of primaries to be able to do increase writes and reads, the average CPU of primary nodes is also reads as CloudWatch metrics, and we can target that metric, and the application autoscaling service will ensure that that metric is met. So it's actually quite a smart service that's trying to figure it out how it needs to scale out or in to be able to match that particular setting or metric that was set. And for replicas, we have an average CPU across replicas. Because as we discussed, memory doesn't really make sense to scale, because if I scale my replicas, they will have the same memory because they're just exact copy of each other. One point to add, we also support custom dimensions.
Okay.
So with the CLI, we can the policy could be configured using custom CloudWatch metrics. So that's another option. We provide these three built-in metrics, I suppose, out of the box.
Okay, that's awesome to hear custom metrics, because I was going to ask about publish and subscribe. I know in the past, one of the main use cases I've used Redis for was applications where we needed to have published channels and then subscriptions. And so we had a large number of clients potentially connected to these channels that we were publishing information on. And one of the dimensions we needed to scale on was number of connected clients, actually, because that could end up being a bottleneck where we had a tremendous number of people trying to connect to a particular channel or whatever. So now, if I understand correctly, I could actually create my own custom metric for that and auto scale my shards based on that.
So just to probably add a little bit more, you kind of bring up a good point. So the CPU and memory, they're kind of like all metrics for class. So if you need to increase more clients connecting, they will require more CPU and memory. So you can kind of catch all metric will balance that out by default for a variety of use cases. So Redis actually outputs quite a bit of metrics, and please talk to us if you need kind of specific metrics that will cover overall cluster. Actually, I'll be very interested in understanding use cases because there is lots of metrics, and kind of providing all of them doesn't make sense. It just becomes too complicated to understand. But if there is something missing and there is a use case which might require additional metrics, please let us know. We're actually very interested in kind of understanding that use case.
Make sure to let us know if you have these things, and also let us know, are you scaling your Redis clusters, and how are you doing it? I would really like to see. According to Nathan over here, it used to be really complex to have a scalable Redis setup before.
It's gotten better every year, and now we've reached the point where this sounds like it's very, very smooth auto scaling experience that I wish I would have had 10 years ago. But now we finally have it today to benefit from.
And probably as well to add, the Redis 6 gets so much better at kind of failover conditions. So when we add shards or add replicas, it's almost a transparent application. The Redis manages it really, really well. And also we've put lots of effort in trying to make it transparent as well. So that scaling operation it does require additional resources on a shard to get rebalanced, and it needs time to create new instances. So there is a considerations there to kind of keep in mind when kind of even setting the metrics and levels of when to scale. So like don't scale at 99% of memory. Because
Yeah,
the
that's
company
one of the things I
Yeah.
wanted to ask about. Like, is there how much is the performance impact associated with doing this scaling? Especially if I'm scaling out a number of shards, maybe, and I need to sync a new shard. What's going to happen during that? And it sounds like I don't want to have the node too burdened down when I trigger an auto scaling.
Yes, for sure. The resharding operation requires network traffic and requires CPU and the memory. So this kind of metrics need to be set kind of sensibly. So let's say CPU about 80-75%, memory at the same time. And also the scaling operation or scaling out, scaling in may take some time. So if you have a very busy cluster that serves lots of reads, lots of writes, it needs time to rebalance lots of data, move it across the network while the writes operation is happening, and then catch up as they go along. So that operation could actually take some time. So setting the kind of sensible values, kind of take into account that the cluster needs to scale, and that might take 15, 20, half an hour. So that cluster doesn't actually get full during that time or doesn't go out of resources during that time.
Okay.
Yeah, that makes sense. If I'm running humongous nodes that have like the 400 gigabytes of memory, and it's going to take at least some time to push all that data over a network connection to a new shard.
Yeah.
That's a considerable amount of data to actually download and then re-upload.
And there's a question actually from Kessler coming in. Are there options to warm up, or are there any cold start considerations when creating when autoscaling Redis and ElastiCache? We talked about there is a delay before this happens, but is there like a way to pre-scale things? For example, we have an expected load at a specific time of day. Can we trigger the scaling somehow through an API call or something?
Right. So thank you for the question. It's actually a very interesting use case, and I'll keep in mind. So we do support schedule scaling. So if you know that, let's say, from Monday till Friday, there is a high load on the application, you can kind of pre-load and kind of scale out or scale in for the weekend. For the target tracking, at the moment, we don't support pre-warming, but this is something that you need to keep in mind. And reach out to me. It's andrewbellic@amazon.com. If you have a specific use case, we'll be glad to talk to you about it.
Yeah, all feedbacks are welcome.
We got another question from Franklin. Is it possible to change node types during auto scaling? If I wanted to add a different node type and then scale at the same time?
No, we only support horizontal, so the vertical is not supported.
Okay.
Okay. Andre, you promised us a demo, right? So we will be having a look at demo right now. Talking about autoscaling is great, and solving operational problems for Nathan with autoscaling is amazing, but we want to see some console. We want to see something happening. Before you get into that, I also want to remind the audience, chat, LinkedIn, Twitch, Twitter, there is a survey in there somewhere. Make sure to go check out the survey. First 50 people who respond to the survey get $10 of AWS credits, so make sure to check it out. It's not because of the money, it's because we want to know, are we doing good? Can we do better? What's good? What's bad? Please do let us know. It is very important. With that being said, Andre, I'm going to bring up your screen. All right, let's have a look. What do we have here?
So I've decided to start this demo from kind of an existing set. So here I have 3 clusters running. I didn't want to create them so we don't kind of waste our time during this demo. And we'll dive in straight into the autoscaling. So here I have 3 clusters, but let's look at this particular one, the autoscaling cluster. So it has 3 shards, and each shard has 3 replicas. So this is kind of a smallish cluster, but I suppose it's kind of very interesting to represent how it works. So with this new release, we support autoscaling, and on the console, you will see a new tab called Autoscaling Policies. And this will allow us to create policies directly from the console. So as I mentioned before, we have what we call dynamic scaling, which corresponds to target tracking in AWS application autoscaling, or schedule scaling. So for this demo, let's start with schedule scaling because it's kind of easy to demo, and actually maybe we will be able to get some results here during the demo. So we do policy demo 1. We have, because scale our cluster once off. So let's say I'd like to scale it during the weekend. So I can set time on Saturday that time, and I can at least kind of get that done, and then I don't have to worry about kind of calling APIs at that time, kind of pre-arrange the scaling or occurrence. Occurrence kind of very easily, if you have daily traffic or weekly traffic, it's a really easy way to set up a cluster. Or let's say if you use it for, let's say, analytical workloads, your cache or ML runs, you can actually scale what those workloads will be run. And daily, weekly, one I suppose bring up is a cron expression. Linux admins love this, so we also provide this. So let me set up one time, and what we'll actually try to do is get that cluster to scale now. So I'm actually in Dublin, so I'm handy calculate my UTC time. It's on we're just 1 hour ahead. And what I'd like to do is scale our replicas from 3 to 4, and we'll add this policy. So what will happen, we'll add this policy, and ElastiCache for Redis will actually orchestrate all the connection between application, auto-scaling service, and ElastiCache, and we'll get all that set up. There is a kind of very detailed explanation in our documentation, how it's done, and also the AWS application auto-scaling has fantastic documentation. There is lots of explanation how that works, parameters for auto-scaling considerations. They have a ton of experience. So hopefully in a bit of a time, if we go back to our cluster, the scheduling policy will get triggered, and ElastiCache will try to get that done.
Will the users notice anything during the scale out? Is there any noticeable? I think we mentioned this, but is there any noticeable effect on performance of existing replicas?
So there should be, from application perspective, there should be no visible drop in performance. But obviously, if we need to move the data along or reshard the cluster, it will require additional resources, and that really depends on how busy cluster is at that moment. But the Redis will add new shards, then drivers should properly work and orchestrate that scale out or scale in transition.
Okay, good.
If I go back to shards, now they're working, and in some time we should be able to get from 3 to 4 nodes for this particular cluster. So it's essentially as simple as that. Obviously, everything that we can see here is also supported through CLI, and a bit more. Just to add, through CLI, we support, as I mentioned, custom metrics, but also we have additional parameters like cooldown periods. The cooldowns could be changed through CLI. It's a bit more of a kind of in-depth, detailed configuration.
And when you say custom metrics, are you talking about any of the Redis metrics coming in, or some? Oh, okay. So you can basically use any. Sorry, CloudWatch metrics. Okay, so basically, based on any CloudWatch metric coming in from a ElastiCache Redis cluster, you can scale out or in. Awesome. That's pretty cool. Cool. I like it. It's very simple.
Yeah, this is amazing to me, just to see that status of modifying automatically. And
click a button.
Yeah, just to click a button is all it takes.
and I'm guessing it's okay. It's right, but I guess there's no additional cost to the auto scaling feature. It's just a feature to Redis in this case, right? To ElastiCache.
AWS application auto scaling, there is no cost. There is cost with CloudWatch metrics.
Okay. Yeah.
And obviously, if I'm scaling out my cluster and adding more nodes or more shards, I'm going to be paying more for those nodes and shards themselves.
Right.
But on the flip side, if I have auto scaling and now I can scale in, that means I could potentially also pay less during the off hours than I was before if I had previously had a really static cluster that was over provisioned and just provisioned at the same number of nodes and shards throughout the day. I'd be paying like the max amount for the max amount of traffic that I serve during my peak, and now I can actually auto scale down.
Yeah, and that's I suppose the primary target for auto scaling is to be able to kind of maintain that steady performance, but don't over provision resources. So that it's not only the cost is optimized for the scaling, but it's also performance. The application can actually access that cache, and it will be kind of at the top performance when needed. Because at the end of the day, customers that use the applications have to be able to really reliable and fast experience. And that's what applications really going to help. Is just track that performance requirements kind of over time and ensure that the ElastiCache operates optimally at any given time.
Was this the one you just scaled out, or this was the old one? Oh, that was pretty fast.
That's done.
I always had like, so I started using ElastiCache a long time ago, and I think that's the last time I used ElastiCache was like to spin up an ElastiCache cluster. It would take a long time and all those things. But I'm quite pleased that I can see that it has actually scaled out in the span of the last couple of minutes where we were talking about scaling. So that is pretty.
I'd like to be fair. This cluster has no data and is not on the load. But like in principle, that's at the minimum time needed to do this.
Okay, yeah, cool. By the way, is there a cost between? So now this, like I really don't know the answer to this one. Once you're doing replicating between one member of the cluster and an additional members of the cluster, and they have a lot of data, is that data being replicated? Is that costing you money, or is that just a thing in a cluster that there is no cost to a customer in this case?
No, there should be no cost.
Okay.
Okay.
Very important. Okay, excellent.
We have a little piece of feedback from Franklin that it would be great to add predictive scaling using machine learning and AI tools. And I know we have some predictive scaling for capacity for EC2 auto scaling. But I guess a little piece of feedback from someone who'd be interested in predictive scaling for ElastiCache as well.
And and I suppose the beauty of our service, we do use AWS application auto scaling, so we'll track the features.
Good. I love it when features build on features. So I think that's just a wonderful thing, because you as a service team, as a product team for ElastiCache, didn't have to reinvent the wheel of your own auto scaling feature or whatnot. So I think this is just wonderful. Yeah. Awesome. Thank you, Andre. Kind of a couple of last questions is that I always have this question: is it supported in CloudFormation?
Yes.
Wow. Okay, there you go.
And that's not information of the beauty of composable architecture, because we use AWS application auto scaling. It's a CloudWatch. They support CloudWatch templates, and from ElastiCache we have support CloudWatch templates.
Okay.
That's fantastic. I'm ready to go set this up with infrastructure as code right now.
Yeah. So excellent. Yeah, I know some services, and I always joke, right? I always ask about CloudFormation, and I know it's not just a matter of like launch a service and then have all of the CloudFormation stuff ready, because we need to be careful on the API and if things change, etc., etc. But I'm always happy when there's a new feature, when I can play with it straight from my text editor. So wonderful. Thank you very much, Andre. Andre, before we go, is there something we can? Is there a piece of content we can point people to? Is there a blog post? Is there something they can go and try out right now when it comes to auto scaling and Elasticsearch?
ElastiCache. Yes, we have our posts, announcement posts, and we have documentation as well. That we can publish.
So
that's everything you need to start on.
So you can start using this, and this is available in all regions where application auto scaling and ElastiCache is available.
We only support 4 regions at the moment.
4 regions. Okay.
4 regions, the same as MemberDB. So it's North Virginia, Dublin, Mumbai, and Sao
Paulo. Okay. So currently available in 4 regions.
Yeah,
check it out.
Working hard on getting the rest.
Absolutely. Cool. Well, Andre, once again, thank you very much. Thank you very much for being part of this. We've enjoyed the presentation. We enjoyed the demo, and also we enjoyed this new feature. So I think this is going to be useful for a lot of people, especially for a lot of people who rely on ElastiCache and Redis. So, Andre, thank you very much, and we will see you some other time.